Hey guys, this is the Unit 4 test review for pre-cal. Number 1, if f of x equals 1 over x is transformed to f of x equals 1 over x plus 2 plus 3, describe all the transformations. Well, if I know that there is a plus 2 in the denominator, that's the b, meaning it went left 2. Plus 3 on the outside, that's the vertical shift, that went up 3. And those are the only changes that happened. There's no a because the one that's in the numerator, that's what came from the parent function. So that's it. That's all the changes that happened. As far as the changes on the second one, there is a 2 in the denominator. I'm sorry, the numerator, which means there is a vertical stretch. If it's a number greater than 1, it's a stretch. If it's between 0 and 1, it is a compression. Vertical stretch by 2, it went right 4, and it went down 7. Because again, the one in the denominator tells me a horizontal shift, minus means right, plus means left. And the one on the outside is D, that's vertical shift, plus means up, minus means down. Number 3, find the y-intercept of the graph of the function below. If I want the y-intercept, I'm going to plug in a 0 for x. So let's do that. So y equals 3, 0 plus 9 over 0 minus 2. Let's simplify. 3 times 0 is 0 plus 9 is 9. 0 minus 2 is negative 2. So our answer is going to be negative 9 over 2. Or if I were to write this as an ordered pair, that would be 0, negative 9/2. Okay, number 4, find the y-intercept of the graph of the function below. Okay, same thing. I'm going to plug in a 0 for x. Y equals 4 times 0 minus 8, and 0 minus 2. Let's simplify. 4 times 0 is 0, minus 8 is negative 8. 0 minus 2 is negative 2. Negative 8 over negative 2 is positive 4. As an ordered pair, that is 0, 4. Cool. Easy day. Let's keep going. Find the x-intercept. Okay, if I want an x-intercept, I plug in a 0 for y. And remember, I only need to worry about my numerator. My denominator is going to cancel out, so I'm not going to stress about it. I'm just going to set the numerator equal to 0. So 2x minus 8 equals 0. Add 8 to both sides. Divide by 2. X is 4. As an ordered pair, that would be 4, 0. Okay, let's get another x-intercept, plug in a 0 for y, set that numerator equal to 0. And that was easy. Our x-intercept is negative 3. As an ordered pair, that would be negative 3, 0. Find the vertical asymptote of the following function. To find a vertical asymptote, we have to set our denominator equal to 0. So x squared plus 4 equals 0. Let's try to solve for x. I'm going to subtract a 4 on either side. X squared equals negative 4. And then if I were still trying to get x by itself, I want to square root both sides to get rid of that square. But I can't take the square root of a negative because nothing times itself is going to give me a negative number. So this is impossible to solve, meaning there is no vertical asymptote. Number 8, let's find another vertical asymptote. Let's set our denominator equal to 0. Now that jumps out at me as something that I can factor. This looks like a difference of 2 squares because I know the square root of x squared. I know the square root of 49. I'm going to have x plus 7, x minus 7 in parentheses. That's what that would be factored, which means my vertical asymptotes are at x equals negative 7 and x equals positive 7. To find the horizontal asymptote, that's the Betsy Bobo Batu stuff. So let's check our exponents. The biggest exponent in the numerator is a 2. The biggest exponent in the denominator is also a 2. So this is a Betsy situation. Betsy. The bottom equals the top, so we divide the coefficients. Coefficient in the numerator is 3. coefficient in the denominator is 6. So our horizontal asymptote is at y equals 3 over 6, which simplifies to 1/2. That would be our answer, y equals 1/2. Let's do another horizontal asymptote. Let's check our exponents. We've got a 2 in the numerator. We've got an invisible 1. Excuse me. There's an invisible 1 in the denominator. That is by 2. Bigger on top, because 2 is bigger than 1. That is undefined. There is no horizontal asymptote. Let's try the next page. Find the horizontal asymptote. Okay, let's get more practice with this. Love it. We got a 2 in the numerator. We got a 3 in the denominator. That would be a bobo situation. It is bigger on bottom, meaning our answer is 0. Last horizontal asymptote. I got a 2 in the numerator. Got a 2 in the denominator. We're back to Betsy. Bottom equals the top, so I need to divide the coefficients. Leading coefficient is an invisible 1. Leading coefficient is an invisible 1. 1 over 1 is 1. Cool. Number 13. Find the domain. So in order to find the domain, I'm going to use the denominator to find the vertical asymptotes. So I'm going to set that denominator to not be 0 because my domain is going to be everything except for where the denominator is 0. So x squared minus 2x minus 24 can't be 0. Okay, let's try to factor this. I need numbers that multiply to be negative 24, add to be negative 2. Well, that's got to be 6 and 4, right? Because 6 times 4 is 24. A negative 6 will get me to a negative 2. Fantastic. Which means x can't be positive 6, x can't be negative 4. So if this question is asking for the answer in interval notation, that would be negative infinity to negative 4, negative 4 to 6, and 6 to infinity. If the answer options are in set notation, we would say x is all numbers except x cannot be negative 4 or 6. Number 14, find the domain of that awesome rational function. Let's do the same thing. We got to set that denominator. X squared plus 5x minus 6. That can't be 0. Okay, let's factor. So I need numbers that multiply to be negative 6, add to be positive 5. Well, that's going to be a positive 6 and a negative 1. Which means x can't be negative 6, x can't be 1. I'm going to write it both ways again. That way you're prepared for whatever your answer choices are. From negative infinity to negative 6, negative 6 to 1, and 1 to infinity. And if I had to put this in set notation, that's weird, that's alright. For my x's, they're everything except x cannot be negative 6 or 1. Solve the inequality. Okay, so remember I need to find x-intercepts and I need to find vertical asymptotes. I use the numerator to find the x-intercepts, the denominator to find asymptotes. So x-intercept is at a positive 6, because I'm going to swap that sign. Vertical asymptote is at negative 2. I'm going to plot those. 1, 2, 3, 4, 5, 6. Negative 2. And then let's use the calculator to help us out. That's not what we want. Let's get a brand new one. Add graphs. Control divide. X plus 2. Is that what it was? Let's double check. X minus 6 on top, x plus 2 on bottom. X minus 6, x plus 2. Alright, so that's what this thing looks like. It looks like up here, it's staying above the x-axis. Here, it's getting next to that asymptote. And of course, it's going to cross at that intercept that we found. It looks something like that. Yeah. So if I want to know when this is greater than 0, I want to know when it is above the x-axis. Well, this piece is above the x-axis, and this piece is above the x-axis. So this piece, that goes all the way to when x is negative infinity. So from negative infinity to, well, it's going to get really, really close to this asymptote without touching, so it's going to stop at -2. And this other piece, it starts here at that intercept where it crossed over to the top. So from 6 to infinity. That would be my answer on 15. 16, same kind of question. Our x-intercept is -5. Got that from the numerator. Vertical asymptote, +8. Got that from the denominator. Go away. Okay, -5. 1, 2, 3, 4, 5. And vertical asymptote is 8. 1, 2, 3, 4, 5, 6, 7. Okay. I'm going to click tab and go back up. That way I can just edit what's already there. What was it? +5 -8. +5 -8. Okay, so I can see what that piece is doing. I know that this piece is going to come up, it's going to cross, and then it's going to get really, really close to that asymptote. I bet there's something happening on the other side of that asymptote that maybe I just can't see. So in my calculator, I need to zoom out. I'm going to do menu, Window/zoom, zoom out. Okay, there's something above the x-axis. I'm glad we checked. So there's something up here, and I know it's going to stay above the x-axis because there's no other intercept, so there's no way for it to get below the axis. It's got to stay above. So if I want to know when this is less than or equal to 0, I need it below the x-axis. This piece is below the x-axis. So this piece starts right here at -5. And because it wants me to include the 0, I'm going to include that x-intercept, -5 with a bracket on it. And then that piece is going to keep going, and it's going to get closer and closer and closer to 8 without touching it. So from -5 to 8 would be when this is less than or equal to 0. As a reminder, when you've got that equal sign, your intercepts need a bracket. Your asymptotes need a parentheses. Number 17, x-intercept at -4 and 2. I'm going to go ahead and draw those. -4, +2. And vertical asymptotes at -3. Cool. Let's graph this thing. Okay, tab up. Will you work it? Oh, beautiful. Oh, but I gotta do that. +4 x -2. I think that's what it was. Let's double check. +1 -2. Cool. X +3 on bottom. +3. Oh no. Alright, that's fun. Okay, so it's going to cross that, and then it's going to go like straight up, getting really, really close to that asymptote without ever touching. And then this one, whoop, again, it started really, really close to that asymptote, and then whoosh, went up like that. So I want to know when this is greater than or equal to 0, meaning above the x-axis. Well, this piece is above the x-axis, and this piece is above the x-axis. So this piece, if I'm reading left to right, which I always should, it starts at -4. And because there is an equal, and that is an intercept, I'm going to put a bracket on it. -4. And that's going to keep going and get as close as it possibly can to -3. That's an asymptote. I'm going to put a parentheses on it. Our other piece starts at 2. Intercept, so I'm going to put a bracket. And it's going to go to infinity because it's going to keep going right, and it's just going to keep moving up and up and up towards positive infinity. So that's my answer. Last one, y'all. X-intercepts. X equals 1. X equals 5. 1, 2, 3, 4, 5. And our vertical asymptote is at 2. Oof. It's going to be a weird graph. That's alright. Math is weird. Weird is okay. X minus 1, minus 5, minus 2. Minus 5, minus 1, minus 2. That's fun. So it's getting really, really close to that asymptote, and then doing something like that. Really, really close to that asymptote, and then doing something like that. So if I want to know when this is less than 0, I want to know when it is below the x-axis. That would be this whole piece and this whole piece. So this whole piece is headed towards negative infinity. It starts at negative infinity, and it's going to stay below the x-axis until it gets right there to 1. This other piece, it starts here as close to that asymptote as it possibly can get, so at 2, and it's going to keep going until it gets to 4. I'm not going to put a bracket because there wasn't an equal sign underneath. That's going to be my answer. Good luck, guys.